Layout of a proof, congruent opposite sides. All right, so we're going to do a proof again. Let's take a look at our board. Having little problems with fuzz here. Okay, now it's clear. Here's our drawing that we need to do a proof. Here's our statements and reasons in our proof table. Statements on the left, given on the right. Here's our given. This is our evidence that we are going to use to do our proof. And this is the thing we're trying to prove, okay? So, let's take a closer look at the drawing. Okay, we've got this triangle. There's a reason for the red and green, which I'll show you in a second. We've got two angles that have congruent signs on each end, and we are trying to prove congruency of opposite sides, okay? So not angles, because that's a side and that's a side, right? So let's look at it. It says given, triangle ABC. All right, well, ABC, that's triangle ABC. And it's given that angle B and angle C are congruent, okay? What we're trying to prove is that the line segment AB is congruent to BC, okay? So, regardless of the ratio of my drawing, it should have been more like an equilateral, but as long as you understand we have a triangle and we're going to prove that this is equal to this, my drawing could have been better. Sorry. So, the best way to do this is to prove that there are two congruent triangles. So, there's a couple of things we're going to need. We're going to need a bisector, and we're going to need perpendicular angles. Now, the way to do that is, even though you're given a drawing like this in homework or on a test, if you need a bisector and you need perpendicular angles, the best thing to do is to put one. There's no reason why you can't. People do this all the time. And it's kind of sneaky because why didn't they give me that in the first place? Well, they want you to think. Sorry. So, you draw your perpendicular line to CB. It bisects this triangle ABC. And it meets at X. Okay? So that means, you know the perpendicular rules, right? That means that these are 90-degree angles, right? So, let's see what happens here. We have our given, all right? So we put that B and C are congruent and that it's given. And remember, what we're trying to do is we're going to try to prove that there's two congruent triangles so that we could prove that that line is equal to, this line is equal to this line, okay? So, we have our given. And then we say that AX, from here to here, bisects CB at point X. Because a line has only one bisector, okay? That's why it does it. So now that we've proven that it bisects it, we can say AX is perpendicular to CB, because it is, right? At point X, see? Our reasoning is a perpendicular bisector intersects a line at a 90-degree angle. So now we've proven that there's 90-degree angles there, which means we can do number 4 and number 5, that BXA is 90 degrees, and AXC is 90 degrees, okay? Our reasoning is perpendicular angles equal 90 degrees, and then number 5 is same as number 4, okay? So now look. Here's what's happened. We've made proof that two triangles have 90-degree angles from where they're bisected, and we've proven that the two angles are equal, okay? So now we're going to say BXA is equal to AXC. BXA angle is equal to AXC because of substitution. If you don't know what substitution is, please go back to video number 30. We've used it several times since then. I mean, we are on number 114 now. Okay, and now because of the reflexive property, which is also identity property, we can say that AX is congruent to AX. This line is congruent to this line because you've now got two triangles and that side is congruent. And it's reflexive of itself, okay? So now, And if you don't know what that is, you can go back to video 27. So now we can say that the triangle of BXA is congruent to the triangle of AXC. This triangle is congruent to that triangle, which is wonderful that we can say this, because now, because of angle side is congruent to angle side, we've proved that the two triangles are congruent. And if you don't know what AAS is, that's in video number 106. We've come very, very far up to be at video number 114. And as I've said before, if you're going to frost a cake, you got to bake it first. You can't jump to frosting a cake before it's even been baked. So if you don't understand this earlier stuff, you need to go back, okay? And they're short videos. They're not really long. You could do this entire geometry class in a like a 2-week period compared to months at a school. Okay, so now, because we've used angle side is congruent to angle side, angle side is congruent to angle side, we can now say that AB is congruent to BC, AB is congruent to BC, because of the corresponding parts of congruent triangles are congruent rule, the CPCTC. That was just a couple of videos ago in number 112. So what we've done is progressively come down. We've used a bisector and perpendicular angles to prove that they're both 90 degrees. Then we've used substitution and the reflexive property to say, hey, you know, they're the same. And because of the angle side, we've proved that both are congruent, and that we can say congruent parts of one triangle are equal to the congruent parts of another, you know, if they're corresponding. So, what I wanted to tell you is, the more proofs you do, the easier they're going to get, okay? And if you want to look at this opposite sides thing, the only way to do it is to do the bisector, okay? And it doesn't matter where you're putting the bisector, as long as you're putting the bisector so that you can say, hey, there's, you know, two triangles, and I can use, you know, side angle side or angle side or one of those rules, or the corresponding parts of congruent triangles one, to prove that one side is equal to the other side, and you've created two triangles, and it makes it easier to do it. So that's the layout of a proof for congruent opposite sides. My next video is going to be congruent angle opposite leg on a right triangle proof. See you then.